factors and greatest common factors. Our objective is to write the prime factorization of numbers, as well as find the GCF of monomials. Who uses this? Website designers who sell electronic greeting cards can use the greatest common factor of numbers to design their websites. Let's start with some vocabulary. The prime factorization. All the factors have to be prime. So the greatest common factor, or GCF, is the product of the greatest integer and the greatest power of each variable that divide evenly into each term. So let's start by looking at writing prime factorization. So we're going to write the prime factorization of 60. So you can choose any two factors of 60 to begin, and then keep finding factors until each branch ends with a prime number. So say we started with 2 times 30. 2 is a prime number, so that one stays. 30 is not. So we have 10 times 3. 3 is prime, so that one's done. 10 can be split up into 2 and 5. So the prime factorization for 60 would be 2 times 2 times 5 times 3. You can also write this, because there's two 2's here, you can write it as 2 squared times 3 times 5. So now that you've seen it, let's practice. So we want to write the prime factorization of each number. So for 40, we can start by dividing that however you'd like. We can start with 2. So if we do, we have 2 and 20. 2 is prime, so we're going to keep that one. And then we can split 20 into 4 and 5. So 5 is prime, so that one stays. And then we have 4, which breaks down into 2 and 2. So now we have 2 times 2 times 2 times 5, which will be written 2 to the third times 5. Let's try 33. So we can start with 3 and 11. Oh, 3 is prime and 11 is prime. So 3 times 11 would be the prime factorization. Try 1C and 1D on your own. See how close you come. Alright, let's see how close you got. 49, we can break that into 7 and 7. Both of those are prime, so it's just 7 squared. And then for 1D, 19 is a prime number, so we can't do anything with that. So now let's move to finding the greatest common factor of numbers. There are two different methods that you can use. Method 1. We can look at the factors of 12 and the factors of 32. So the factors of 12 would be 1 and 12, 2 and 6, 3 and 4. And then the factors of 32 would be 1 and 32, 2 and 16, and 4 and 8. The common factors are 1, 2, and 4. None of the other ones do they have in common. Well, since you want the greatest common factor, the greatest one that they both have is 4. So the greatest common factor is 4. You can also use your little factor trees that we were just working on. That's method 2. So let's look at 12. We have 3 times 4, so 3 is prime, and 4 breaks down into 2 times 2. So we have 3 times 2 times 2 is the prime factorization of 12. And then for 32, we can break it into 8 times 4. 4 breaks down into 2 times 2. And then 8 breaks down into 2 times 4, and then 2 times 2. So the prime factorization for 32 is 2 times 2 times 2 times 2 times 2. So you have one more step here. Okay, so you have a set of 2's in common and then a second set of 2's in common. So each time you have a set, you write it once. So one set of 2's, another set of 2's, and then we have 2 times 2, which is 4. Our greatest common factor is 4, much like it was up here. Method 2 is great if your mental math is not the greatest. If you have really strong mental math, it might be faster to use method 1. So let's practice finding the greatest common factor of each pair of numbers. Take a moment and try it on your own. When you return to the video, we'll go through the answers. So for practice, for the first one, we're going to use method 1, and then in the second one, we'll use method 2. So we've listed out all the factors of 24 and the factors of 60, and the largest one would be 12. So the greatest common factor of 24 and 60 is 12. You can do this part in your head if you have really good mental math skills. If not, even writing out some of them sometimes helps you out. Now we're going to try B using method 2. So 18, the prime factorization of 18 would be 2 times 3 times 3. And the prime factorization of 27 is 3 times 3 times 3. Well, we have one set of 3's in common, and we have another set of 3's in common. So we have 3 times 3, which is 9. So the greatest common factor of 18 and 27 is 9. Now let's try finding the greatest common factor of monomials, meaning now you have some variables. My suggestion is to think of your numbers as separate from your variables. So if you look at 3 and 6, what's the greatest common factor of 3 and 6? Well, that would be 3. And now you're going to deal with your variables. So you have x squared and x to the third. Well, you're going to take the smallest, so x squared. Reason being, you can't have a greatest common factor that's larger than what you started with. With least common multiple, something you're going to be learning later on, you would have taken the larger one. So greatest common factor, you can think of factors are smaller, so take the smaller. Multiples are bigger, so when we learn LCM, you would take the larger one. So this was a little foreshadowing for you. However, in the end, when you find the greatest common factor, so factor is smaller, you have 3x squared for this one. So now let's try B. So what's the greatest common factor of 4 and 5? Well, the only factor they have in common for numbers is 1. And then we have x squared and y to the third. Well, those are all x's, those are all y's, so there's nothing in common for those either. So the smallest is to have none of them, so therefore your greatest common factor is just 1. Let's try a couple more just to be sure we have this. So what's the greatest common factor of 18 and 27? Well, the greatest common factor between 18 and 27 is going to be 9, just like we had done earlier in the video. And then we have this g squared and this g to the third. So because we're doing greatest common factor, so smaller, we're going to take the smaller one here. So that's g squared. And now let's try this one. So we have 16 and 9. The greatest common factor between those two is just 1. and then we have some a values. We have a to the 6th, and then we have b. Well, they don't share anything in common there for variables, so it's just going to be 1. Now let's try a technology application. Garrison is creating a web page that offers electronic greeting cards. He has 24 special occasion designs and 42 birthday designs. The cards will be displayed with the same number of designs in each row. Special occasion and birthday designs will not appear in the same row. How many rows will there be if Garrison puts the greatest possible number of designs in each row? So here's a hint. The 24 special occasion designs and 42 birthday designs must be divided into groups of equal size. The number of designs in each row must be a common factor of 24 and 42. So what's the greatest common factor of 24 and 42? Well, if we think about all of our factors of 24, and then we think of all of our factors of 42, the greatest common factor is going to be 6. So how many rows will there be if Garrison puts the greatest possible number of designs in each row? So we have one more step. We have our 24 special occasion designs divided by our 6 for each design per row. So that gives us 4 rows. And then we have our 42 birthday designs. So we've got 42 over 6. So 42 divided by 6 gives us 7 rows. So when the greatest possible number of designs is in each row, there are a total of 11 rows. And that ends our lesson on factors and greatest common factors.